Okay, so I got this far. I'm doing it with the Z table first. So I put my two um, Z scores down here on my number line. The negative 2.165 goes right here. The negative 1.35 goes right here. I'm looking for the area in between those two. So this area in here, that's the area that I'm looking for. And so I need to use this formula, the area to the right of the right z. So I went and looked up negative 1.35. Negative 1.35 is right there. 0.0885. 0.0885. I wrote that down. Now I'm writing down this one right here. But notice that most of the time the z-scores have just two decimal places, negative 1.35. This one has three decimal places. So it's not going to be exactly on the table. So I wanted to show you what I'm going to do. Negative 2.165. So negative 2.16 is right here. Negative 2.17 is right there. So right between these two would be 0.065. Halfway between 0.6 and 0.7 would be 0.65. So right halfway between these two right here is going to be the number that I need. So this number right here is 150. This number right here is 154. So what do you think is halfway between them? What about 152? 0.0152. So that's what it. That's I don't think. Yeah. 0.0152. That's halfway between 150 and 154. So that's the number that is going to go here. 0.0152. And then we're going to go to the calculator and subtract those two. 0.0885 minus 0.0152. And the answer is going to be 0.0733. 0.0733. That's the area between those two. The probability that the z value is between these two z values. Okay, I'm going to check this on the calculator. Should be the same number. We have a starting place and a stopping place. I don't know why I keep hitting that button because it's red and I'm tired. Menu 652. Starting place is negative 2.165. My stopping place is negative 1.35. Standard deviation and mean are 0 and 1. And they got negative 0.0733. Not negative. I don't know why I said negative. 0.0733. Okay, so this number and this number come out to be the same. All right, so last problems, there's several of them here. The only difference is that this time we are going to have not just a z value, but we're going to have an x value. So an average of 22. What do you think the word average stands for? Mean. So my mean's going to be 22. And my standard deviation is 9. So again, we're going to have the same thing. We're going to have a starting place. We're going to have a stopping place. And if we're using the calculator, these are going to be my two new numbers. Okay. So the problem here is that I've only given you a Z table, or if you want to use the Z table, then you have to convert this X value that they give you right here. You have to convert that to a Z score. So this says find the probability that the student works. So that's X, because when we're not working on we're working with actual data, then we're finding the probability of X, not the probability of Z. I can convert it to a Z, but we're going to do X. Find the probability the student works less than 4 hours. Okay, so I'm understanding that this means I'm looking for the area to the left because it says less than. The problem is I don't know where 4 is, because this is a Z number line, not an X number line. So if I take this number line right here, X, I know that this 0 right here is going to be 22 on the X number line, and the standard deviation is going to be 9. So one standard deviation away from 22 is 22 plus 9. So 22 plus 9, that's 31. 31 plus 9, that's 40. And 40 plus 9 is 49. You following me? I'm doing my standard deviations to get, excuse me, to get my X scores that correspond with my Z scores. So 22 minus 9, if I take 10 away, that's 12. So it's 13. 13 minus 9 would be 4. And then 4 minus 9 would be -5. So these are hours per week that a student works. Jobs worked an average of 22 hours per week. So an average of 22 hours per week. So all of the number of hours that a college student is going to work is going to fall between -5 and 49. Now, yes, -5 doesn't make sense in this case, but to follow this standard deviation, that's what our 3 standard deviations away would be. So to find the probability that X is less than 4, we can see right here that 4 lines up perfectly with the Z value of 2. It's not just a matter of lining up. I'm going to show you that we were going to calculate, but we're looking for this area right here. Okay, we're looking for this area underneath here from 2 on down. And if we use that formula that we did a while ago, Z equals X minus mu divided by the standard deviation. In this case, we have X is 4. There's our 4 right there, minus 22 divided by 9. And 4 minus 22, that's -18 divided by 9, that gives me -2. So you see that the X value of 4 corresponds exactly with the Z value of -2. So when we're finding the probability that X is less than 4, that's the same thing as finding the probability that Z is less than -2. Those are going to be the exact same number. If you're using a calculator, you don't really need this. You need this to use the Z table. If you're using the calculator, then you can use this the same way, because what do we need? We need a starting point. Where are we starting? At -infinity. And we need a stopping point. Where are we stopping? At -2, or we're stopping at 4. If we use this, then we're going to use 0 and the standard deviation of 1. If we use 4, then we're going to use 22 and a standard deviation of 9. So I'm going to go to my calculator, and I'm going to do menu 652. My starting place is -infinity. My stopping place is, I'm going to do X. So my stopping place is 4. My standard deviation was 22. I'm sorry, my mean was 22. My standard deviation was 9. Press tab, and you're going to get that. The area is 0.0226. So I'm going to write 0.0